Hey guys, Mr. Jenkins back here with your first lesson of Chapter 6, your first lesson of the second semester. So let's get off to a good start. Chapter 6 is all about solving systems of equations that have two variables. So today, specifically, we're looking at how do I solve a system that has, by using graphing, all right? So that's why kind of yesterday I wanted to go over, again, how to graph a line and whatnot, but so you got to be able to do that. Okay, on that note, we will get right to it. So again, you know, here are your learning targets. We want to be able to solve systems of equations by graphing and then analyze special systems, right? So, you know, again, if you have a system that has two variables, it's got to have two equations, all right? And then solving by graphing is a natural place to start because we see visually what does it mean to find a system, a solution to a system of equations. And the answer is it's the ordered pair that fits both of these, right? And sometimes there's one ordered pair that fits both. Sometimes there's infinitely many. Sometimes there's none. Okay, so in example 1, we'll see where they have one unique ordered pair solution. Okay, so just graphing these, A and B are easier because they're already in slope-intercept form. So looking at graphing A, we're going to start at where B is 2. So I'll graph this one with a dot, and then I'll graph the other one with an X so you can tell the difference. So we're going to start at 0, 2 for the top equation. Let me make that just a little bit bigger just so we can see those grid lines a little closer. So starting at 0, 2, and then from there my slope is 1, right? So I'm thinking up 1, right 1. And then I like to kind of continue it on. And then we could go that way as well. That way we can really tell what the pattern looks like. All right, so my other line, B is -2. So I'm going to start at 0, -2. And again, I'm going to make an X mark instead of a dot just so I can tell the difference because not everybody has the colors like I do. And then my slope is 3. So that means up 3, right 1. Or I could go down 3, left 1, right? But you can tell that if I kept going this way, they're going to get further apart, whereas if I keep going this way, they're going to get closer together. So let's see what happens again if I go up 1, 2, 3, right 1. So that's that point of intersection right there. I'll go ahead and finish it. So you'll have to do a lot less work on your graphing. On Math Excel, you just have to graph 2 points. Guess I didn't really need to make all those points. But then the next thing you need to do, the last thing you need to do is be able to recognize what is that ordered pair. So a lot of times, you know, I've seen so many times where a kid does all the work right, and then they'll say, all right, the answer is, let's see, that's 2, and that's 1, 2, 3, 4. So the answer is 4, 2. Well, that's incorrect because 4, 2 is right here, right? So they don't intersect there. So just be careful. That is 2, 4. Or you could say it like this: X equals 2 and Y equals 4. Okay, and that should check out algebraically. So what I mean is if I plug 2 in here for X, I should get 4 out for Y. If I plug 2 in here for X, I should get 4 out for Y. I would just check that in my calculator real quick, which I don't need to here. I know 2 plus 2 is 4, good. And then I know if I plug in 2 here, I get 6 minus 2 is also 4, right? So that's pretty easy, and I wrote all that out on the notes. I'll leave B for you to do. And this might be helpful to maybe print out these notes, okay? That could be an adjustment that you make that could turn out to be really helpful. All right, looking at C and D, they're a little bit tougher because they are not already written in slope-intercept form. So we'll practice solving for Y a little bit. okay? Eventually, I'm going to show you something to where you might not need to do that, but for now, we will solve for y. All right, so first step here would be move over the 4x. If it's 4x over here, it's minus 4x over there. So that would give me negative y equals negative 4x minus 1. And then I want to divide everything by negative 1. So that gives me positive y equals positive 4x plus 1. All right, let's go ahead and graph that one. So I'll graph this one with a dot again. So starts at 0, 1, and then my slope is 4. 1, 2, 3, 4 over 1. And I'll go ahead and stop there. That's all you'll have to do on Math Excel as far as graphing. And then my other one, okay, all I have to do here is move this over there, and then I'll have y by itself. Remember, that's plus x over there. So on the left side, I have y equals. On this side, I have x plus x is 2x. And then the minus 5, I'll graph that using x marks. So I'm going to start at 0, negative 5. And then my slope is positive 2, so that's going to be up 2, right 1. Okay, so if I extend my lines, I can kind of tell they're going to get further away going to the northeast. So that must mean they're going to intersect somewhere down here in the southwest, right? So I'm going to just continue my pattern. And again, this is the part you don't really have to worry about as long as you get these first two right. Actually, I'll just show it that way because that's how Math Excel will do it for you. So Math Excel will do the extending of the lines for you. Do that without really making more points. And let's see. Not great. Okay, so it looks like they intersect right there that's going to be negative 3, negative 9. Make sure that's right. Sorry, negative 3, negative. Well, yeah. See, I wasn't very accurate with my lines, so let's just do that again. All right, so in this case, I'd want to keep extending. So down 1, 2, 3, 4, right 1, 1, 2, 3, 4. And then let's see if they intersect anywhere. Down 1, 2, left 1. Down 1, 2, left 1. So I would need to actually keep going. Down 1, 2, left 1. This would be down 1, 2, 3, 4, left 1. So they actually don't intersect until we get to negative 3, negative 11. Negative 3, negative 11. Again, that looks tougher on mine because it goes off the graph, but that won't happen on Math Excel. So that part will be a little bit easier. And they extend the line perfectly for you. So this one is not as obvious, right? Does it work in both? Well, let's just see. Let's just see algebraically if it works in both. So I'm going to go back to the original. So on the top one, that would be 4 times negative 3 minus negative 11. What's that equal? That'd be negative 12 plus 11. That'd be negative 1. So that checks out. And then in the other one, here we have negative x, so negative negative 3, plus y, so plus negative 11, equals x minus 5, so equals negative 3 minus 5. So this does check out. This would be positive 3 and minus 11, so that gives me negative 8. Over here I have negative 8, so it checks out on both. okay? So that was a little bit of a tough one. All right, so, you know, this one may be as well. All right, so let's go ahead and work through that. And then this is the main thing to get from this lesson is example 1. So that's why I'm spending a little time on it. All right, solve this one for y. We get y equals -½ x plus 2. All right, and now you're going to tell me what do we get on the next equation when you solve that for y. Answer should have been y equals ½ x plus 6. Okay, so if you got that, good job. If not, that's because we just moved the -6 over. And if it's -6 over here, it's +6 over there. So y equals ½ x plus 6. All right, so my top line, I'm going to start at 0, 2, and then my slope is -1/2. So I'm going to go down 1, right 2, and there you go. Okay, my other one, I'm going to start at 0, 6, 2, 3, 4, 5, 6, and then my slope is +1/2, so that'd be up 1, right 2. Okay, so they're definitely getting further apart as we go to the right, so let's keep going to the left and just see where they cross real quick. So up 1, left 2, up 1, left 2. Looks like probably there. Let's just make sure. So down 1, left 2, down 1, left 2. So there you go. So that's the point -4, +4, it looks like. So you can do ordered pair, or you can say x equals -4, y equals 4. And just in my calculator, you know, I could just type that in real quick. So y is 4, so I could go 4 plus, you know, 1/2, which is 0.5 times x, which is -4. And I get 2, so it fits that equation. Let's see if it fits this one. So y minus 6, 4 minus 6 is -2. If I do half, just make that a 0.5. If I do half times -4, I also get -2. So it works in both. Okay. So you've seen this before in pre-algebra. Depending on, you know, it may have been during the last quarter. So you may not have as solid a base as my kids last year, but I think you have seen this before. All right, now let's do an application problem, everybody's favorite, which is also known as a word problem, okay? All right, so this one says 1 satellite radio service charges $10 per month plus an activation fee of $20, right? So automatically think MX plus B, so which one's M, which one's B? Your per month is going to be your M, so M is 10. B is your one-time fee, so that's going to be 20. So for this one, we will say Y, which will be the cost, equals 10 times X, which is the number of months, plus 20. All right, so I'll go ahead and start that one. My scale here on the y-axis looks like I'm counting by 5, so I'll take note of that. So 0, 20 looks like 0, 4. And then up 10, you got to be careful here. Up 10 looks like up 2, right? Up 10 over 1. Okay? And then our other one, the other company charges 11 per month, and starting cost is 15. So M is 11, B is 15. So that one's going to be Y equals 11X plus 15. All right, so here I'm going to start at 15, which is simple enough. But then the question would be, what's up 11 over 1 look like? Okay. This is where we have to use our problem-solving skills, right? So let's kind of scale that a little bit. So 11 over 1, I want to make this a multiple of 5, right? So I'm gonna multiply that by 5 and that by 5. So I'm going to change it to up 55 and right 5. Okay? So up 55, that's going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So that takes me from 15 to 70. And then right 1, 2, 3, 4, 5, because I'm counting by ones on my x-axis. These scales can really mess you up. And then so let's see where they cross. So I'm just going to follow this pattern. Up, looks like up 2 over 1. And finally, we see that they cross right there. All right, so they cross at 5, comma 70. So the question says, in what month is the cost the same? So just to answer the question, we're going to say 5 months. Okay, I've shown all my work to support that answer, so that's all I will say for my answer. Okay, so that one's difficult, and again, sometimes problem solving comes into these, so maybe you don't think about scaling this up to 55 over 5. Another thing you could do, and this kind of gets to something later, if you're solving these that are both in y equals mx plus b form, if you get to the test, maybe you don't solve it right by graphing, but maybe you think, okay, I could just set these expressions equal to each other and basically make it a DMR problem. So this would be kind of another approach to get the same answer. So if I did 10x plus 20 and set that equal to 11x plus 15, and again, this kind of previews one of our next lessons. And solve it real quick. So I'd do minus 10x to both sides. That's going to give me 20 equals x plus 15. Then subtract 15 from both sides. It'll give me 5 equals x. Right? Which we know is the answer. Okay? So that would work as well. All right, so last one, we will look at some IMS and no solutions, what those look like. So let's just look at A and B. All right, so let's graph the top one in blue. Okay, so we're going to start at 0, 2, because B is 2, and then M is also 2, so that would be up 2, right 1. And so then we have our line. Maybe. All right, and then our other one, we'll graph in green. So it's going to start at 0, negative 2, and then its slope is also 2. So if I go up 2, right 1. Okay, we kind of learned this last chapter, but parallel lines have the same slope, right? So since those both have a slope of 2, you could follow that pattern forever, and they're never going to get closer. Parallel lines do not cross. So this would be an example of a system that has no solution, right? Because we're looking for that point of intersection. So if they're parallel, they're never going to cross. They have no solution, okay? And some of these math books use a different term. You might hear that called, well, I guess that's what they use here. There's like consistent and dependent and stuff, but I don't really care about that, just as long as you know that's no solution. All right, so then the last one, the big part is just your ability to solve for y. So once we do that, it's pretty simple. All right, so looking at our top equation, we're going to move minus x over there. That's going to give me 2y equals x plus 2. If it's minus x over here, it's positive x over there. Then I'm going to divide everything by 2. So that would give me y equals 1x divided by 2. That's 1 over 2x, so half x. And then 2 over 2 is plus 1. So after that, we have the exact same equation, right? If you have the exact same equation, it's going to produce the exact same line. Okay, so my top equation start at 0, 1. My slope is half, so up, rise 1, run 2. That's obviously the exact same line as this. So if you have two equations that produce the exact same line, that means that every point on that line is a solution to both. So this one has IMS, infinitely many solutions. And again, some of this stuff should sound familiar, okay? I'll leave C and D for you. Those are on the filled out notes. You can check those out. The biggest thing on these is solving for Y. And then let's kind of summarize, the pattern that you see here. Okay, so what do they both have in common? Our special cases, right? You can't really see this, but they have, IMS would have the same M, same slope, and the same B. All right, so same M, same B equals same line, so that would be IMS. And the way they make that not obvious is you have to solve for Y. Or no solution would be same M. So it starts the same way, but a different B. Okay, and then if they have a different slope, then they're going to have one solution. All right, so different slope has one solution. Okay, so that's a good thing to know as well to finish out these notes. So there you have it. We'll definitely do a day, at least a day of extra practice on this. We'll probably cover this for the rest of the week, so make sure you get off to a good start and ask questions. In tomorrow's class, we'll have a Q&A day. Hopefully you'll be able to knock out most of this assignment.